force. So this is one of the questions from the book. It says that you have a coal barge. If you don't have any idea, that's a kind of barge that they carry coals over the sea or open surface waters. And it says that it has 1,000 feet length, 100 feet wide, and it is submerged around 20 feet in the water. And the velocity is 12 meters per hour. It gave you the temperature, so probably any kind of water properties would be read from the table of the relationship between temperature and the rho, nu, and other water characteristics. So here, as you can see, if the water temperature is 60, you will have these two numbers, nu and rho. So these two came from the temperature. And it asks for friction drag. FD. So this is all we know about the problem. If you remember from the formula, FD was equal to this one, area V2. So you have the velocity, you have rho, you can find the area, but CD is not the one that you have. Probably based on the graphs and tables that you have, you should find it. Since it's a long barge and the depths and the width in comparison with the length is very small, so I can assume it's a plate, right? And I can use the graphs that I have reading the number of CD for the plate. But this is the one that I'm going to use. As you remember, I need RE. Again, for the exam, I will provide this kind of graphs for you in case that I need you to read the number. So I should find the Reynolds, first of all. And I should make sure that I'm in a turbulent flow. So first, I'm going to find this guy, nu x2 nu. Should be 5, I think. What are these numbers? This is unit change from meter per hour to feet per second. You should multiply the number by this guy. This is new, which we have it already. I'm going to find x, and this is the threshold for turbulent. So first, I will assume that my flow is turbulent, okay? And see what would be the x, what would be the length. If I find x, x is going to be 0.343 feet, which means that if my length or the dimension that I'm working with is more than this number, I'm in turbulent. All the data that you have, 1,000, 100, and the 12 feet are more than that. So you are pretty sure that you are in turbulent. So until here, I'm just checking. Check if I am in turbulent region. And I mark that. Now I'm pretty sure that I'm in a situation of turbulence. I'm going to start finding my real Reynolds, which is the same thing that I have. Velocity is the same. L, I'm going to use the length of the barge because drag is going to be through all the length of the barge. And nu is the same again. And if I found that, I will have this number, which shows that again, I'm in a turbulence. Again, the first part is somehow an extra part. You don't need to do it unless I ask you to check if you are in turbulence. Otherwise, you can assume that you are in turbulent section or region. So the first section, the first section, I'm just checking that. Now I have the Reynolds. Before I go and read the number, probably if you check the solution, you will see that one here. The solution says that if you are going to find CD, use this formula. I haven't talked about that. This is in the book, but this is one of the formula that you can check your CD. This graph, this formula shown in this one, I'm going to use this graph. This graph is equal to the formula that you can see in the solution. Okay, the solution that I have is the equation of this graph. I'm assuming that I'm in a turbulent and I have a smooth plate, which is this line. So I should probably mention it in the text of the problem that it's a smooth one. Otherwise, you should know what's the epsilon over L. Your number is over than this number. If you notice, it was like 4 point something, 1.4 multiplied by this. But as you can see, these are going to be all horizontal. So if I'm here even, probably I'm somewhere here. So my choice is 1.5, 0.0015, 16, something like that. Again, the solution is here. Probably if you read that, you have no idea what's this one. But I said that we use previous slide for CD, which is the graph for that. So back to my solution. I will consider CD as this one. Maybe you have more, but I checked this one last night and I noticed that my answer is very close to the one that the solution have. Back to the formula, FD equal to, I had the rho was 62.4 multiplied by velocity square, 12 multiplied by this number, divided by area. Area is a bit tricky, so this is the part that I would like to explain that. You have a barge, which is this one. If you take a look at that, you have one surface, which is this one. So the drag is affecting this guy. You have something at the bottom, which is submerged. So this is number 2. And you have the same here as well, which is number 3. So you have 3 surfaces that drag goes through them. 1, 2, and the bottom one, which is the third one. So you should consider all of them. The length of all of them are 1000. So I'm going to keep 1000 here. This one is 12, this one is 12, this one was 100. So I can do it 3 times, but instead I can write it like a sum of all of them. That's the reason that you see the solution has 3 surfaces. Drag at the bottom, drag at the side. I won't consider the top because there is no water on the top of that. It says that a part of that submerged. So I just need to take care of the three ones. So that's rho, that's CD, V square, the whole, this guy is area. The one that I have is this number. The solution is a bit different, but I'm going to, oh, there is another thing that you should multiple, the changes between pound and the feet ones, which is going to be multiple by 1 divided by 32.2. Don't forget that one. So this is the part that you should write. Here we go. If you do that, you will end up FD, this one, and the unit is pound. So two things I would like to mention and insist on that. First of all, CD. The solution give you a formula for CD. No need to use that. You have a graph to read that. And consider that you have a smooth plate, which leads you to this line, the red line. Two, be careful about the area. If this is the barge, I have one at the bottom and I have two sides. This one doesn't going to be included because the force is perpendicular to that one, which is lift, not the one that I would like. So drag is something that you should have literally drag on that. So you need to have surface tension on that, which is the below one, the two side. Up, no, because there is no water there. I consider bottom and two side, and this one no, because the force is perpendicular to that one. So this is my answer. This is the one that the solution gave to you, and the reason is the difference between our consideration of the CD.